Hello everybody, welcome to your Unit 1, Section 1 review. You should only be watching this video if you are in the B group, or maybe if you're in the A group and you just love what we've been doing so far. But if you're in the A group, you don't have to watch this video. You have already taken the Section 1 quiz, and we went over this stuff in class. So B group, we are shooting this as a supplement to today's class. So you should have your Unit 1, Section 1 Cambridge Journal out and open. You're going to be handing this in next time I see you. And let's get to it. So the first 2 pages should be completely done. You should have already read the Chem Talk and answered the checking up questions. So we're going to start by going over the checking up questions, and then we will hit the essential questions at the end. Alrighty. So in your own words, right, checking up questions. In your own words, describe 3 differences between an element and a compound. This might be something you want to star. Hint, hint, wink, wink. You might be seeing something like this later. So, one difference between an element and a compound is that an element cannot be broken down. Right? We showed, right, in our lab that a compound can be broken down into its separate elements using methods of chemical separation, but we cannot break down an element. Right? Another difference here, we have elements can be represented by either atoms or molecules. Let's try to extend this block just a little bit. While compounds are always represented by molecules. Alright, so oftentimes our elements will just be one single atom. There are times where we have more than one of the same type of atom chemically bonded together, something like O2, right? Oxygen is naturally found with 2 oxygen atoms bonded together. Same thing with nitrogen or hydrogen. Right? And these would be smaller subscripts as well. And then lastly, elements are shown or represented, again is fine, shown with symbols, while compounds are shown with formulas. Right? Or you might say compounds have more than one capital letter. Right? All of those would be acceptable answers there. And you could even have some more differences that I didn't even describe. And if you want to get them confirmed before you take the quiz, just shoot your chemistry teacher an email. We should be by our computers today. Alright, so why are symbols useful in describing chemical elements? Well, the first thing is that it saves a lot of time and space. Right? Another reason is that sometimes these chemicals are very difficult to spell. One of the next labs you're going to be doing is the temperature curve of paradichlorobenzene. And just think about the amount of time and space it would take to write paradichlorobenzene consistently over your paper throughout the day. So because we can shorten elements into symbols, we can come up with shorter formulas for our chemical compounds. If we have to write a chemical equation, it doesn't take up a full entire page. So yeah. And then, so you should have already come up with the names here. C should be carbon. Cu should be copper. Right? It's Cu because it comes from the Latin word cuprous or cuprum. And it can't be Co because that's already cobalt. Au is gold. Right? Comes from the Latin word aurum. Mg is magnesium. He is helium. And lastly, we have Fe, which is iron. It comes from the Latin word ferrum. And then number 4, we all know that chemical formula of water is H2O. What kind of information does a formula provide about a compound? So looking at this, right, H2O, the first thing we are told is that there are 2 hydrogen atoms. Or maybe we should start with this. There are two different atoms, hydrogen and oxygen. And then we have, there are two hydrogen atoms. There is one oxygen atom. All right, I don't see a coefficient in front of my compound here, so I can assume that there is only one molecule of water here. All right, so we can, just looking at that formula, we can break down every single type of element that is present and how many of that type of atom we have, as well as how many molecules we have. So that wraps up our checking up section. You should feel pretty confident about that. Now let's get into our essential questions. Okay, so you're going to get used to the format we have here, but the first thing you need to know is that we break this into three sections: the macro, the nano, and the symbolic. So macro is going to be what you can see with your own naked eye, something on a larger scale, while nano is going to be what's happening at the atomic or the molecular scale. If we could hop on the magic school bus and drop down to the size of an atom, what will we be seeing? And then symbolic will be when we draw a picture. So this is when you're going to have to be very patient with my ability to draw on the touchscreen here, but we'll figure it out. So let's get started with the essential questions. Describe what you observed in the decomposition of water during the electrolysis demo in class. So oftentimes in this description, students want to say that they saw a bubble. Unfortunately, that is not descriptive enough. When you tell me that something is bubbling, a lot of times I'm thinking of a toddler blowing bubbles with one of those little straw type things that they have. So we need to be as descriptive as possible. So the most descriptive I could see, or the most descriptive I've seen so far in class, is we had one group that's had something that sounded like this. So when the switch to the power supply was turned on, many small bubbles, right? Not just talking about the fact that there are bubbles, but how many are there, what did they look like, and what were they doing? So there were many small bubbles being made at the electrode. All right, and then they were quickly rising to the top of the tube. All right, so you should have seen a steady stream of those little bubbles, right, going up towards the top. And as they were going towards the top, they would then pop, push our water level down, and we would have more gas in there. So you should have a nice detailed explanation there. At the nano level, what we're seeing, right, is that as electricity goes into our water molecule, it's separating from each other. That chemical bond is being broken. So we're starting with, right, something like H2O, or water. Right? But then we add some electricity. Let's see, how can I word this? Describe what has happened to the compound water during electrolysis. So I would say the compound of water is being broken down into its separate elements, and these elements are hydrogen and oxygen. All right, so if we could really get down there, we would start to see that the hydrogen atoms, or molecules, I guess, because it would be H2. So hydrogen molecules are attracted to the negative electrode. I'm sure you've heard the term opposites attract. While the oxygen molecules are attracted to the positive electrode. Right? And using those different charges that we have is what separates our water into its different atoms. And then lastly, draw a picture that represents the decomposition of water. Draw a picture of the molecules and write the chemical formulas below the pictures. So you should see, right, something like this. We have H2O. And remember, you can draw a much better picture than me. So this would be our water molecule. And we have a little bit of lightning coming into it. Or not lightning, electricity. But we're going to draw that in the form of a lightning. Look at that. That is beautiful. All right, so when electricity enters in here, right, we then get, right, our H2, or our hydrogens, and our oxygens separate. Whoop. And that should be O2, right? So this is what our products are. So if we have to write that chemical formula, our chemical formula would be H2O as a liquid, right, plus energy, or if you said electricity, that would be fine. And it produces, right, hydrogen gas plus oxygen gas. Alrighty. Very good. Alright, now we got a couple more questions here. The how do you know? So water is often referred to as H2O. What evidence do you now have to support that water is made of hydrogen and oxygen? So you should be answering this question here based on stuff from our experiment. So did you notice like the certain levels of the gas being created at a faster or slower rate? Right? Did one of those point towards that ratio that we have of hydrogen to oxygen? Did we test those gases, and what were the results of those gases? Did that help us prove that those gases were what was making up water? So you want to be referring back to that. So you might remember that one of our gases, when we took a flame to the bottom, made a popping sound. Another one was able to reignite just a glowing flame. And then when we had the mixture of the two, we had a very loud pop. And then there's one last page here, so don't forget to answer this question, the why do you believe? So individual elements behave one way when they are alone and one way when they are chemically combined with other elements in a compound. Create an analogy that is true from parts of your life to show how sometimes people behave one way when they are alone, like an element, but differently when they are with a group. Really, I don't think there's a better time for examples like this. I know we might not see all of our friends or peers throughout the day, but I mean, if we just look at examples in or from the news recently, there's a lot of people that have made some decisions that they probably wouldn't have made if they weren't in a group setting. So whether you want to come up with something broad or something more specific to your personal life, that's completely fine. But there are times where we all act different, and I want you to share that below. And then that would be the end of your CAMI journal. Don't forget to bring this to class with you on Tuesday so you can hand this in, and have a great rest of your snow day.